Here we have a specialist maths question about summing random variables. So this one is about the time taken for Sam to vacuum the house, V. He's also mopping the floor, which is a random variable, M. And then we asked about the sum of those two random variables to be the total time that he takes cleaning the house. So V plus M is C. So we should define our random variables. V has a mean of 1, standard deviation of 0.3. And M has a mean of 2 and a standard deviation of 0.4. So then we want to find the expected value of C. So using the sum formula, it's just going to be the sum of the expected values of V and M. And that formula is on your formula sheet. So that sum is just 3. It's a 1-mark question. So the answer is 3 or 3 hours. Next one we want to show the variance is 0.25. So the sum of the variances formula is also on your formula sheet. In this case, again, it's pretty simple. It's just variance of V plus variance of M. So we sum those two values, 0.9 plus 0.16 to get 0.25 as expected. Now, we should be aware that the variables are independent. Otherwise, we could not use that formula, okay? So that sum of variances formula only works for independent variables. Actually, I think I noticed a little error there. I'm not going to change it, but there's something not quite right there. I wonder if you can pick it up. You can leave a comment if you like. Anyway, moving on. So he wants to clean the house before a friend visits at 1 p.m. If he starts cleaning at 9 a.m., what is the probability the cleaning will not be finished by 1 p.m.? Well, that means the cleaning would have to take more than 4 hours, or more than or equal, I guess. And we're given that information about the standard normal. So we're going to turn this random variable C into a standard normal by subtracting the mean and dividing by the standard deviation, which is square root 0.25 or a half. And conveniently, that works out to be 2. So we know 0.9545 between -2 and 2. So greater than 2, well, it's going to be 1 minus 0.945. But then we divide by 2 because we only want the top half of the curve there. So then it's just a matter of calculating that value. This is exam 1. We don't have a calculator here. But if you are able to do that, then you're better at this sort of thing than I am, but that should work out to be 0.023. I'm just kidding.